And in today's class, we are going to learn about a very powerful concept in C++. It's called Lambdas, and usually it is used together with the algorithms that we just learned during the last class. And if we see in A2, most of the things that we're using are algorithms on some containers like unordered map and unordered set and a vector. So in today's class, we're going to see how do we, what are these lambdas, what do you even mean by lambdas, and how to use them, what's the syntax, and then we'll be moving on to the object-oriented programming in C++. Okay? So first let's just start with lambda. So before I start, are there any questions about anything about the course or assignments or project or anything in general? Okay, I think let's get started. So these are just the two topics that we're going to discuss today. And first topic, lambdas in C++. How many of you have used lambdas in any other programming language like Python? So first let's start with whatever we left off in the last week. Okay, the last week we finished our lecture with this function called transform. Okay, with this algorithm called transform, which takes in the int b stands for the input vector, takes in an input vector. Just one more thing, I forgot to inform this. We are actually recording this lecture. Okay, we are recording this lecture. That's camcorder here. So people who are here, if you are uncomfortable, I think no one will be there in the video. But if you are uncomfortable to be before the video, please make sure you can move aside if you want. Okay. So we have this this is the input vectors begin iterator. The int b again stands for the input vectors end iterator, and we have output vectors begin iterator, and then there is some function we have to provide here. So what this does is take this input vector from this range from the beginning to the end and start transforming this vector by applying some function on that particular vector, and starts outputting the results or placing the results starting from this particular location. Okay, the out v dot begin from the output vectors begin. And now, just to understand more about this, let's assume we have a square function. We even saw this in last class. We coded this thing. So there is a function called square, which takes in an integer and just returns a square of that particular integer. Very simple. Okay, this is like a normal function in C++. And then now let's see if we want to write the square function. What are the things we did? Okay, in our code. So we have a main. So we called something okay, int y is equal to square of 3, and we actually now we have to first declare in C++. We have to declare that function there. Okay, we have to say okay. Because program execution starts at main, here we have to say that for the compiler, okay, when you start reading the program from main, you will see something like square. Don't panic, because I will be defining it somewhere at the end of the program. So this is a function declaration, and then we have something like the definition. Usually people write main first, then followed by other functions, because when people start reading code, they try to search for main, okay? And because that gives the logical flow of the program, right? And that is the reason we have it like this. But if you have the function definition of square before, okay, before the main function, you don't need that declaration. If you have the function definition of the square function before the main function, you don't need the first line function declaration, because the compiler again starts reading from the starting of the file. And when it comes to main, it would already know what square means, what the function square means, because you have already defined square. Okay. Now, just to add a simple function like this for transforming a vector to some other vector, we have to add a function definition and then a function declaration. This is actually a very simple function, and for this very simple function, we have 3 lines of definition and 1 line of declaration, right? And if you want to use this is the int vector, like a sample, let's take this as a sample input vector with these integers. And then if we have this function, this transformation, okay, this transformation is now being applied on this input vector, and the output is going to be stored beginning from this output vector. Please note that we need not specify what is the end iterator for the output vector, because all this transformation is concerned about is just okay, I have to transform this range of elements and I have to start outputting the values starting from this location. And how many ever values are here in the input vector, it tries to just keep on creating those many values in the output vector. Okay, and this is the function. The function is squared. The square function which we just saw in the previous slide. Okay? This is the square function that we are applying right there. Okay. So when this transformation is applied, before this transformation, obviously we would have created this output vector saying like, okay, std : vector of int out v, okay, and we would have created, we also, in the last class we did this, we also created this output vector, okay, of size equal to the input vector. So output vector has been created of size, it starts with a fixed size of 5, and when you don't initialize anything, the values, the default values in the vector is 0. This is how it looks like. And then the first element gets transformed. This is how you should think of it, like, okay, now this vector, all the elements in this vector is like, okay, it starts from here, it is going to come here, okay? Like each and every element gets transformed based on this particular transformation. And so now 3 becomes 9, 2 becomes 4, 9 becomes 81, and 4 becomes 16. So the main thing about std transform is like the input vector is untouched or unaltered, okay? It remains the same. Only the output has been created a totally new vector called output vector out v, okay? And the transformation that has been applied for this particular thing is the square. We have applied the square function on all the elements in this vector. Now, let's stop there. And any questions in std transform? Because this is the base for us to like start learning lambdas. Yeah.
So if I run the out way of begin and plus 1, will the out way be used completely? I mean, how will the mass number in the square?
So the question is, okay, the question is, in this particular piece of code, what if I give this the output iterator to be outv.begin plus 1, okay? What if I start writing the output from here, okay? If you start writing the output from this particular location, 49 will come here, okay? Then it will keep on going till 81, and there will be no space for 16, right? So it would be like, it depends on how the vector is implemented. You have to go and look into the implementation of the vector, like to see, it may even create, I really don't know what would happen, maybe it will even create a new element, or it is just like undefined behavior. You cannot like guess anything on that. We have to check the manual for that. I mean the CPP reference of transform. Any other questions?
So the output vector is another.
Yes, it's a totally different vector. Yeah, not even a copy, it's totally different vector with different values.
So I can still have access to the original.
Yes. So after a transformation, you would have access to both the input vector and the output vector, because both, you just created both. And so it did not override any of those things. It has just created a totally new copy, okay? Okay. With that, then we are moving. Any other questions regarding transform, std transform? Because std transform is like one very useful algorithm. Yeah.
So if you wanted to modify the input vector, you would have to set that equal to the output vector with those reference to what we originally had.
That's a very good question. So what if, okay, so the question is, what if at this particular location we have, okay, in v input vector dot begin, it would just start rewriting that particular vector. If you don't want to create a new copy, but just, if you want to just square that particular vector that you already have, you just do in v dot begin here. So it means the input is from there to here, and the output is again starting from this particular location. So it will start reading 7, square it up, and then write 49 in the position where 7 was previously, the same exact location. It's a very good question. Okay. Now I think let's move to something like lambda calculus. Okay. Let's see what lambda calculus means. So this is like again some introduction from mathematics. A function in normal mathematics is like defined like this. Okay, square of x is equal to x square. Okay, so everyone is able to understand this. If we will say something like, we will learn something like, okay, y is equal to f of x. That f is a function on the what to say, the independent variable x and y is the output of something like that. So we can have something like square of x is equal to x times x. And in lambda calculus, okay, the same line, square of x is equal to x times x, can be represented like this. Okay, this lambda calculus is a field in mathematics, can be represented like this. So what this means is like, okay, x is being transformed into, okay, x is being transformed into x times x, that's it. So the function, the same function, square of x is equal to x times x, is in lambda calculus is written like this, okay. So what is the important thing that you observe here? Like what is the difference between these two lines? Anyone? Here in this particular first line we have the square, okay, the name of the function, what that particular function is doing. But in this particular line we have totally removed that function's name altogether. Can you see that? There is no name for this function, but we just say, okay, there is something called x and it just gets transformed to x squared. So if x is 3, then the answer or the output of this particular function is going to be 9. If x is 7, the output is going to be 49. That's it. Say that's it. But it has removed so many syntax from there. Syntax in the sense, it has removed the name of the function, it has removed those like the braces here and stuff like that. But it is like not so easy to understand. If someone does not explain what this means, it may be difficult to understand. Okay, and this particular idea from the lambda calculus has been directly applied in C++. Okay, let's see how it is being applied and why it is useful. So again, we take the same square function, we have the name of the function, the return type, we have the input parameters, and we have the body of the function. Now this function using lambdas in C++ will be transformed into something like, first we just remove the name of the function. Think about it, we are going to like write functions without any names. Isn't that cool? So we are just removing the name of the function. The name of the function is gone, okay? The next thing is, we are removing the return type. We don't even worry about what it is returning. Just remove that one. It's gone, okay? But this looks very ugly, right? The C++ developers even made it like slightly more ugly by actually adding something like this. Okay? Now, that same square function, okay, using lambdas is represented like this. Okay? The first two square brackets, if the compiler reads those two square brackets without anything, it means that, oh, okay, the user is actually defining a lambda here, a function without any name, okay? But if you think about it, we had that x maps to x square, right? That left hand side of that arrow is this particular input, int x. So we have the int x here, so the input parameter or the argument still remains in the function. And since it is a function, the curly braces still remain. And then we have the body of the function, the definition, actual definition of this function also right here, return x times x. Now, this same thing we will not even see like this in real code, it would be like this, one liner like this. Lambdas usually will be written like this. How many of you have seen this syntax when you went into like CPP reference for something? Yeah, you could see this thing at so many places. The whole idea here is like try to understand what this means and also try starting to use it. I can definitely say you, if you understand lambdas very well, and if you start using lambdas, you would start using them so frequently that the amount of lines of code that you will be writing for any, like what to say, whenever you apply some algorithm or something like that, will become so less. Become like nearly 1/5 of whatever you usually write. Okay? And so this is how a lambda looks like. So it's like very abstract, we really don't understand what this means. And so if you want to like apply a lambda on a particular transformation, this is how we do. So the right hand side of this assignment is that lambda, okay? Now we are capturing that whole lambda, okay? We are just saying assign this lambda to something called, and the name itself is lambda. This can be anything, this can be function, this can be this can be like square or anything like that. This is just a name. The lambda here is just a name, okay? This is just a name. And do you guys remember the auto type specifier? We need not worry about what the type of the right hand side thing is. So as of now, we really don't know like what type lambda is. Lambda is a function, but a special type of function without any name or without any return type. When something like that exists, there is really no type in C++ for lambda. They would have some type associated with it internally, some function type, but we as programmers really can't specify a type for lambda. And since we need not worry about it, because we have this awesome auto keyword. I really am not going to worry about what this variable is going to be, this lambda. Just assign it the value of the right hand side equation. That's it, okay? Right hand side is like the unnamed function. This may even look like we are talking about some language totally different, not even C++, but please bear with me. And once you find out how useful it is, then you really appreciate it. Yeah.
So since it returns an integer, would it still be okay to have like an auto type for lambda? Is that just saving the function or the value that's returned?
So it's like the function. So here this lambda, this variable lambda just means it's actually a function.
Okay.
A lambda function. Okay. But this name can be anything. This can be just f or fn or functions, anything like this. This is just a name that are given for this particular lambda.
So
Okay.
what's the purpose of having auto then? I was having trouble understanding why we need to.
So let's assume if we don't have auto here, we have to, this is a variable that we're declaring in our program. We have to define what type this variable is.
Okay.
This is not an integer variable. This is not a double variable. This is not a vector variable.
It's a function.
This is a function. We are collecting it as a variable.
Alright.
So we have no idea, right? It's above scope or something like that. So, but okay, the main idea here is lambdas and auto were introduced together in C++ 11. So lambdas would not work without auto. Like something like that. You guys understand? It was, yeah?
Where is this line of code put?
Pardon?
Where do you put this in the code? Like
This can be anywhere. Assume this is in main right now. This can be the first line in main. Okay, we are going to do some programming and show you how to exactly do this. Okay, so you can assume that this is like the first line in main. Okay, and then immediately the next line, what we are going to do here is the same transform function. Okay, see here this transform algorithm. The NV, all the things are same. Here instead of having the square function, which was so simple and easy to understand, we are just complicated stuff, right? And now this is we have applied this lambda, we told okay, now apply this lambda for this particular transformation. So this line of code is exactly the same as writing that new function, okay, called square, having a declaration for it and giving the name of the function inside this transformation. Both the things that we just saw are exactly the same, okay. But one more useful thing here is, usually the code would be written like this. See here, in the next slide, we are just removing this temporary variable called lambda and just placing this lambda right here. That's how usually we will see code. So it will transform from this input vector dot begin input vector dot end, start placing the things in the output vector and just apply this transformation. That's it. Now, if you think about it, the reason is we may not even use the square function anywhere else in our program. If we don't even use the square function anywhere else in the program, it is unnecessary to create a separate function and to maintain it. We have to even think about it. We have to even write the comments, right, for the function, what that particular function does, and we have to write a declaration for the particular function. Now, all those things can be avoided by using lambdas. Now, this just says input vector. The same thing, instead of the square function, you are actually writing your own square function right here as the last argument of transform, saying that this is the transformation that I want to apply on this particular input vector. So the input is an integer. Okay, why the input is an integer here? Because the vector that we are considering is a vector of integers, and that is the reason. It means, okay, when I am going from this particular, this particular inv.begin to inv.end, all the elements that I am going to access are integers. So for each and every integer, I pass it through this particular lambda, and whatever is returned as the value, which is the x squared, I am going to save it in the output vector. That's all. That's all this means. And this particular thing, just this syntax means that whatever we are writing after that is a lambda. It would have no name. Any questions about lambdas? So I think like so as of now I'm like giving you the context of lambda calculus and everything, but when I first saw some code like this, I was terrified really. Like coming from C++ 2003 or something like that, when I just saw C++ 11 code, something like this, I had no idea what was going on. And then I figured it out by myself, trying to learn like, okay, what this means, what each and everything means. So you may, even though we learned C++ in 2016 right now, if you go and work in C++ with C++ in 2018, you may be using the 2017 version of C++. At that time, you may be seeing much more things like this. So the main thing here is, here we're just, my whole idea here is like to give you some idea of like how to learn C++, but the skill of like, okay, how do you learn it by yourself is like very important that you should like take away from this class. And that is the reason also in assignments, whatever you have in assignments, everything we may not be able to cover in the lecture. You should figure it out by yourself, okay, on your own.
So the square brackets just like
The square brackets is just to inform the compiler that the thing that is coming after that is a lambda. Okay, and there is one more use of the square brackets which we may be seeing like while we are like doing some live coding. Okay, shall we move? Okay. Now we are going to like just look at some demos of this particular lambdas, whatever we just saw. Okay, let's just start this. So we have empty file. We can. So think about it. So if you want, again, let's start with the vector. Okay, let's start with the simple vector of ins. And let's say this is v, okay, or in the same way you can just say in v, okay. And to have this include vector, we have a vector include now, okay, and then just in v dot begin, sorry, in v dot pushback. Just some 3 numbers maybe. Just adding some 3 numbers to the vector, 3, 7. And 4. Okay, these 3 numbers to the vector, and let's just start applying the transformation for this particular vector. So to apply this transformation, again we need one more vector for the output vector, right? So this is the out v, okay, the out v, and then on this particular out v, we are going to apply a transformation. So on the in v, we are going to apply a transformation. So std transform, and whenever you want to apply any algorithm, you should include algorithm header, okay, the algorithm header, and then you go and apply the transformation. It's in v dot begin, in v dot end, then out v dot begin. But for out v, we have to specify the size here. So here I am specifying the size to be the input vector size. Size is input vector dot begin. Okay, this is how you specify a size for a vector when you create a vector. You just do it in basis, and then now at the end we are going to create a lambda right now. Okay, so I'm just maybe moving it to the next line here. Okay, the 4th argument, I'm moving it to the next line. Okay, so lambda, again the symbol, then the input, what it takes, some int n or int x or anything like that. And then it's a function, right? So you just have it like a brace here, and then it's going to just return x times x. Or sorry, this is n, so it should be n times n.
Did you mean nv.size or nv.begin?
Oh, sorry. This should be nv.size. That's a very good catch. This is nv.size. So you have to get the size of the x. And here we say this thing. And this is a normal statement like we write inside a function, so there should be a semicolon here, okay? There should be a semicolon here. After the semicolon, the lambda is done, and you end the particular transform with the semicolon, okay? The exact same thing as we just did. Now, one more cool thing, okay? We usually write a function, okay, for printing a vector, right? If you think about it, now we can print a vector. There is another algorithm called for each, okay? There's another algorithm called for each. Now I'm trying to print this first. I'm trying to print this input vector right here. Okay, so it's td for each. Okay, that's the algorithm called for each. For each is very similar to transform, but it just does not create a new vector or something like the output vector. It just applies something on each and every element in the input vector. Okay, the input and the output is the same here. You will just overwrite it, or you can do something. So using for each, now I'm going to just use a lambda to print the vector in a single line of code. Okay, so again the same thing is going to be in v dot begin, in v input vector dot end. Okay, and now for printing the whole vector, okay, we are going to create a lambda here. So again a lambda, then everything is an integer, right? So everything is just an integer. So in, let's say n, and for every integer that this lambda gets, just print that particular integer on the screen. So it's just going to be std cout n. Maybe we can place a comma at the end. Can move this a little bit? Okay, I'm placing a comma at the end and I'm finishing this particular line of code, and then I'm going and finishing this for each. So for each element in this particular input vector from the beginning to the end, just apply this lambda. So this lambda just says, take this, I know that this integer contains, this vector contains integers. So for each and every integer that is coming inside this lambda, I'm just going to print that particular lambda on the screen. So this shows that you need not, lambdas just need not return some values always. You can, it is an actual function itself, but the only thing is like it does not have any name there. Okay, so now let's see how this works. So in the same way, if you want to like create, if you want to print the output vector, you would just like maybe copy this particular code and just do this for, first let's just check like incremental coding, first let's just check if this works, then let's proceed maybe. Yeah, can you see that? Lambdas in C++. In one line we just printed a vector with the power of lambdas. Can you see this? 3, 7 and 4 has been printed there. Okay, let's maybe print one more empty line at the end. Okay, just printed an empty line at the end, and now let's just see if the same thing can be applied for, okay, for another, maybe we can now make this particular line of code to be a function, okay. So I'm just creating a function here called the print vector with that particular line of code, which takes in a vector of integers and then prints that. Okay, so this function has been created here, print vector, and for each, whatever we had there just became the function, and this says just in v. It need not be in v right now. We can just change it to just v, because it can be any vector now, okay? Not just an input vector. I'm just changing it to v, okay? And so, I don't know what it means. We can remove that. Okay, now we can go and safely call this function on this particular vector. If you want to call it on the output vector, after this transformation, you can just say this is the output. Okay. Can you see that? This is the input vector, and after the transformation, the output vector, and the print function printing a vector, we did not use any iterators or any loop or anything like that. We just wrote a single line of code for printing a particular vector using lambdas. How many of you think this is cool? I really think this is so cool. Great. This is so awesome. So think about this. Your code becomes so less, and that's the reason we even had that number of lines of code in like Gerald's implementation or something like that less than. Initially I had like for so many functions I had like 1 or something like that. Then Varun told me no, maybe you should not have it like this. You should have like at least like less than 5 or less than 10 or something like that. And so I just changed it again. The reason why every line of code was just like one line is because of lambdas. So even if you have not started A2, don't worry, you have got the superpower to finish it like in like 3 hours or something like that. Okay? So with this, then what we are going to do next? So we saw like about lambdas, and we saw again one more thing called std for each, right? For each just does this for each and every element here. Now one more thing we can see with the lambdas is, what if, okay, what if you want to like say delete some stuff from a vector. So in the same vector we have like 2 odd numbers and 1 even number, right? Let's assume if you want to just delete the even numbers, or maybe we can add like 2 more elements to the vector. 8, 5. Okay, there are 5 elements in the vector right now. So if we choose the vector, it's like this. we want right now to delete all the even numbers from this particular vector. Okay, let's see how can we do that. Again, as we so whenever you want to delete something, all you have to do is like use erase remove idiom. So I'm going to use erase remove idiom right now on this particular input vector in v dot erase. Okay, in v dot erase, I have to do two iterators. The range which I have to erase, the first iterator is going to come from the remove algorithm. So the remove algorithm is going to be std colon remove, but I'm going to like remove something that's only an even number, and so I cannot just use remove. I should use a created version of remove called remove if, okay, with some condition. So we have remove if, okay, remove if the apply the input vector in v dot begin in v dot end, okay, and then just apply. Here you are going to like for the remove, we are going to give instead of a number. If you remember remove, last time we just gave a specific number called 3. Remove all the 3's from the thing, okay, from the input. Here we are going to say, but here it's not just a single value, but we are going to apply a function here as an input. Okay, we are going to do a function as an input to remove it. So again, we need not create the functions right now because now we have lambdas, right? So just go and create a lambda here and just say I'm going to like int x, okay, and all you have to say is in this particular lambda return, okay. So whenever if you want to check if a number is an odd number or even number, you write a function something like is even, okay, takes an integer and you will check if that number is an even number using like modulo arithmetic and then return true or false. This is how usually function is even function is returned. Applying the same logic here, I am thinking like x is an even number, and so all I have to do is if x mod 2 is equal to 0, then I should return true, right? So I'm just going to do the same thing, return x. I know this is like the simplest way to write this, x mod 2 is equal to 0. Okay, so this is a boolean. This will evaluate to a boolean. This particular highlighted piece of code will evaluate to a boolean whenever the number is an even number. Hope everyone understands this. This is pretty simple. And so now if it's even number, it returns true. And so whenever this particular thing returns true, what happens is like this remove algorithm will move it to the end. Okay, this remove algorithm will move those elements to the end. I mean, it will make sure that it has to remove those elements, and then we use the erase to do that. And we know that along with this is just the first argument of the arrays, and second argument of arrays is we have to apply the input vectors end, right, in v dot end. And I'm applying that here. So this is an erase remove idiom. You will look at this so many times. Okay, so let's try now running this and let's try printing the input vector again here. Okay, let's just copy this line of code and let's just print this input vector again. So I do not have a new line here, so maybe I can just copy a new line and add this new line inside the function so that every time we need not have a new line. Can you see that? The even numbers 4 and 8 have been deleted or erased, removed from the particular vector. We only have 3, 5 and 7 right now. Okay? What if, here one more like complexity or something like that. What if someone says, okay, so when I just told remove all the even numbers, we wrote a function for it. What if I want to pass something, okay, pass some number and I want to remove it. So let's assume the user in this particular thing, the user wants to remove one particular element. I mean like all the elements that have the value 3 or something like that, okay. What if the user says like that? And maybe let's duplicate some elements here. So for that particular reason, let's say, let's even move them somewhere. I'm just like reorganizing this, okay. Okay, now the vector looks like this. Okay, there are like now 3 5s here. So now if the user says I want to remove all the 5s, okay, how can we do this? Now again, after this, let's say, okay, assume this is the number that you're getting from the user. Let's say num is equal to 5. Okay, assume this has been got from the user. Now you want to remove all these 5s. Now again, you may try to go and use the same erase remove idiom. So I'm just copying this particular line of code and just pasting it here. But instead, in this lambda, it's not just going to be, okay, x mod 2 is equal to 0, because we are not going to check for even numbers, but we are going to check if that number x is equal to 5, right? If x is equal to 5, then it should return true, else it should return false. That's the condition here. Does this make sense? But here we are just like hard coded this value of 5 here, okay? But what if the user wants to like provide it using the cin every time the program runs? Then we have to pass in that variable n to the lambda, right? Does it make sense? Do you understand the problem here? Well, the problem is, how can I make this generic? Instead of x is equal to 5, how can I make it x is equal to this num? This num that I have here, okay? Think about this. This is like in the main function, like 31 is in the main function. And this particular lambda is like a function altogether, okay? It's very similar to a square function or some function. If you remember, functions are self-contained, right? Functions just cannot access any other variable from the outer scope or anything like that. If you are inside a function, you can only access the local variables and the arguments that come inside the function, right? You cannot access something in main. So we have the same problem here. In lambda, this lambda cannot access this num directly, okay? So what may be the immediate thing? Okay, we may think, okay, now let's go and just like pass in that particular num along with this x. So if we pass in this particular num, this may be one solution, okay? But just you yourself just look at this. If you are the compiler, okay, how will you even identify which is that integer out of these two integers? Okay, this should be num, okay? This should be num, okay? Which of these two integers, okay, are the actual values that are coming from the vector, okay? And which one is the other integer that you want to compare? The compiler cannot identify that. Do you understand that? The compiler cannot identify which is the particular element for each that I'm going to apply this particular transformation or I'm going to remove, and which is the number that I should compare with. It cannot like distinguish between these two. So this is like incorrect. So lambdas cannot do something like this. But already along with the awesome power that lambdas have, now lambda has one more superpower, okay? And this superpower is called capturing the context, okay? By capturing the context, here we mean this is the context, okay? The context is now we are in the context of the main program or the main function. Inside this particular function, inside the main function, we want to capture some variables that we may use inside the lambda. And that is the reason why we had this particular thing all along. Till now, we did not even use this, right? We only had it as, okay, like a syntax for lambda. Compiler will understand that if the compiler looks at this particular square brackets, it is a lambda. But now we are at a problem where we want to like capture some variables from the environment that is outside us, which normal functions cannot do other than parameter passing. But in lambdas, parameter passing is not so easy in a way like you cannot like distinguish between which one is from the vector element and which one is actual number you are referring to. And so here using that thing, here we are going to say inside this double quotes, we are just going to say from the outside context, which is the main function, can I capture the context? Can I capture the context of just this variable num? I just want the variable num to be captured. So I just say inside this, I just say I'm capturing the variable num inside this lambda from the outside context, which is the main function. And once I capture that particular variable num is accessible within the lambda. Does this make sense? This is why we have that square brackets. Usually, most of the things most of the places we won't capture the context. But if you think about this would be so useful in your A2. Think about it like this num, instead of capturing the num, there you will be capturing the stop words. You may just capture the stop words and use the stop words to just remove it using a lambda directly. You can just check, but yeah. But this is the idea. Now let's see if this is removing this particular all the files from this. We should actually print this again. Yeah, you see this? All the 3 files from this particular thing have been removed using our lambda, where we did not even hard code, but we have this variable num accessible inside the lambda. And if you want to just capture multiple variables, you just give like a comma and just keep on going. You can just here, you can just say comma some. If you want to capture the output vector or something like that, just say out v. If you want to capture the output vector, this is just I'm giving some dummy examples, but this is how you do it. But if you want to capture output vector by reference, okay, by reference you have to like do that ampersand sign before it. I think like at least half of you don't understand this by, what do you mean by value and by reference. Maybe I will try to go over that like sometime next week. At a very high level, okay, by values, like we are making a whole new copy of the particular variable and sending it to the function. By reference is like we maintain that variable or that particular container as it is inside the main function, and we are passing just a reference to the function to directly go and modify the value inside the variable or the container in the main function. That's the very high level idea, but yeah, we can discuss in detail. One more thing is like if any of you are like not very comfortable about any basic concepts about programming, feel free to like come talk with us. We'd be like we would like we would really help you understand if because these are like very high level concepts. If you really don't understand what do we mean by pass by value or pass by reference, please come talk with us during office hours or even set up appointments. It would be really helpful for you to like maybe even attend interviews and stuff like that, guys. Okay. So yeah, so this is how you pass like multiple variables to a lambda if you want. Like this particular thing is not called passing variables. This particular operation or this particular idea is like capturing the context. Okay. So whenever you hear capturing the context, it just means like okay, now lambda has one more superpower where lambda can directly access the variables from the outside context by giving those variables inside the square braces. Okay. This is how lambdas work. Any questions about lambdas? Yeah.
So that remove if is like remove combine with the
Yes. So remove if, okay, remove if is what to say, modification or like modification of the remove algorithm, where in the remove algorithm you have to specify a particular element here. You have to specify which element you want to remove from the vector or the container. But in remove if, you can pass in a function here. You can pass in a function all the elements that match or that apply for all the elements for which this function returns true. Remove all those elements.
So the function has to return true or
the function has to return true. Yeah, this function in a remove if the lambda should return a boolean. Okay, in a remove if this lambda should return a boolean, true or false. Then only remove if will understand should I remove that element or not.
Does remove if return an iterator to what you're removing?
Yes, remove if, like very similar to in the last class we saw, right? What remove does, it just pushes the needed elements to the left and the unwanted elements to the right, kind of, and then returns the iterator to the first unwanted element. And so this whole line, this first line, line 32, in line 32, this whole line just means that this will return an iterator to the first unwanted element. So in this particular case, the array would have become 3, 5, then 3 elements, okay, some 3 elements. So 3, 7, and you may assume like 5, 5, 5 or something like that. Okay. And it has returned the iterator to the first 5.
So it would only remove the first instance, right? Not the or would it return? How does it get rid of all the instances?
Because we are saying like, okay, so it's more like, okay, 3, 7, 5, 5, 5 is there, okay. Now this returns iterator to the first 5, and we know that the things are pushed to the right, and so if we remove till the end of the vector, which is given here in v.end, just go till the end and remove all the elements. So we know that all those are unwanted elements. Very good question. Yeah.
How do lambdas handle method overloading? Like if you save a lambda and you had it's doing like similar things, but like just based on like the number of parameters. So would you have to define a different lambda?
I'm not very sure about it.
Okay.
We can check that out because like usually we try not to complicate lambdas more than this. In the sense we try to use it like because it's more like you would not reuse lambdas. If you think about lambdas, it's not like something that you would reuse. You only use it for that particular line of code.
Okay.
So you would not even like. It is not even appropriate, I would think, to do something like that for a lambda.
Okay, makes sense.
Yeah.
In the function body for lambdas, can we use other functions that we define elsewhere?
Yes. In this particular, you mean like inside a lambda?
Yeah, inside the lambda, let's say in like a separate file, we define a function, like some function, and
Yeah.
use that function within the body.
I have not tried that before, but I think definitely we can do it because lambdas have what to say, all the capabilities of normal function. I think we can do it, but maybe some more complex syntax for capturing that particular function or something like this. This lambda should know that function exists or something like that. You can like check that, and if you want, you can discuss. So one more thing is like, since we are saying like lambdas are like just normal functions, right? You can even have lambdas like, as we just told, you can just say auto, and this is the lambda that I am having, like this is not a keyword, okay? Or you can just have this lambda function or something like that, lambda fn. This lambda is int x, okay? If I pass in an int x, it would return, let's say, return x plus 1 or something like this, some simple lambda. You can have lambdas like this also, okay? And then if you want to call this particular lambda, all you have to do is std cout. You can just call this lambda function with that particular argument, like let's say 3. I think this may work. Let's check. Semicolon somewhere. So here inside the lambda, see here I forgot, this is like a very common mistake that we make when we start learning lambda. You see here, I just forgot the semicolon at the end of the lambda because it is just like a normal statement there, right? So I just add a semicolon here and then I try running this. You see this, the number 4 is being printed. So here we have just used a lambda as a normal function. You see that? I created a lambda on the left hand side, I created a lambda on the right hand side, and then stored that particular lambda in a function called lambda underscore fn. Just gave it a new name because we don't want you guys to get confused that if lambda is a keyword in C++, lambda is not a keyword in C++, but if you are aware about Python, actually lambda is a keyword in Python. The same idea is also there. And so we just apply in the CO, we just say, okay, apply this lambda function on this particular variable. This is like more, now when you see this thing, it will be so simple or something like that because you already seen how to use lambdas along with the what to say, standard C++ libraries, algorithms and containers and stuff like that. Okay, so I think I will not be able to start classes and objects. We can start afresh in the next week. So yeah, that's it. I hope like I have given you guys like a superpower in C++ in today's class. Hope you make use of it. Like just remember that great power comes great responsibility. Okay.
Go back to